Thank you for joining us for today's webinar, Cold Fluid Applied Waterproofing Membranes. We have some brief housekeeping before we start. Your phones are on mute. If you have any questions, please type them into the Q&A box in the corner of your screen, and we'll answer them at the end of today's session, time permitting, or via an email after. And you can always send questions to mapeidigital@mapei.com. This is an AIA accredited webinar. If you're joining us live, 1 LU credit is available. Please send your AIA number if you're interested. Now, without further delays, I'd like to introduce today's speaker, John Humbrecht. John is currently the concrete restoration and waterproofing specialist for MAPEI Corporation in the Louisiana-Mississippi Territory. He works with architects, engineers, consultants, contractors, distributors, and he brings complete MAPEI product solutions to job sites. He's been with MAPEI for 5 years and has more than 25 years experience in the construction industry in commercial and industrial product sales and applications. He's a member of the ICRI Gulf South chapter and is active in local AIA events and presentations. So with that, John, the floor is yours.
Well, thank you, Jen. Welcome everyone to the webinar today on cold fluid applied waterproofing. As Jen said, my name is John Humbrecht and I work for MAPEI as a concrete restoration and waterproofing specialist. I currently live in the New Orleans, Louisiana area, and I tell you, I think this is a great topic we're going to talk about today because waterproofing really affects all types of projects in the construction industry, regardless of where you are. Let me see if I can get us going here. This program, I'm not sure if Jen mentioned it, but it is registered with AIA CES for continuing professional education credits, as you saw on the previous slide, and it is certified for an architectural learning unit credit. So let's get right into it. Today we're going to discuss the nature of waterproofing and hopefully gain a good understanding of the entire process of preparing for and installing a cold fluid applied waterproofing system, including the types of warranties that are available, which is important. And then following this AIA portion of the presentation, we'll show you some real life practical product applications and products, including some job site pictures that'll hopefully help you with your specifications and simplify the installation process for contractors. So let's start off talking about the difference between waterproofing and damp proofing. You see these terms, I think you see them interchanged a lot, and let's try to understand the real difference between them. It's actually pretty simple. So waterproofing refers to resisting water under hydrostatic pressure, whereas damp proofing only resists water in the absence of hydrostatic pressure. And one way I like to demonstrate this, I often tell people it's kind of like you have your cell phone. You get caught in a rainstorm and it rains on you, get a little bit of water on your phone. Usually not a problem. You dry it off, not an issue. I guess in that case, you could kind of say your cell phone was damp proof. But you take your cell phone to the beach or the swimming pool, drop it in the deep end, and it sits there for a few minutes, and obviously you usually have an issue, and that's because you have a lot more water pressure and it was able to force its way into your phone. So unless you had a special case on your phone, it probably was not waterproof. So that kind of shows you the difference between the two. It's also important to note that damp proofing will not usually bridge cracks like a waterproofing material will. Waterproofing materials tend to be very flexible once cured. Here we see, if you look at the diagram here, that as the height of the depth of the water increases, so does the hydrostatic pressure. If you picture that wall down there indicated by the H, or the height, as the wall of a building that goes, say, 10 feet below grade, you can see how the hydrostatic pressure would be higher near the bottom. especially as the water table rises, that water toward the bottom of the structure is going to be going to have a lot more pressure on that bottom area of the wall. What are some of the characteristics of a waterproofing system? Well, it obviously needs to prevent water intrusion. It needs to be continuous. This is very important, regardless of the type of system. And if there's a way we know for water to penetrate a structure, given enough time, it almost always finds a way in, even where areas that you wouldn't suspect it would get in. These products are permanent for the duration of the building. So, you know, I'd like you to picture, say, you know, we talk about the permanence and how long this needs to last, say, underneath the building. Picture an elevator pit that's located, say, in the central part of a large office building. Well, you know, once that slab is poured and the building's constructed, there's likely never again going to be an option to waterproof the outside of that elevator pit. I mean, you just probably wouldn't be able to excavate underneath that building. So you want to make sure that it is a durable, robust system that will last the lifetime of the building. And of course, it's always very important that it's installed by a reputable waterproofing contractor. When we think about ways that water can enter the foundation of a building, well, there's lots of ways. We talked a little bit about the water table in the previous slides and how that can create hydrostatic pressure. I've seen many issues with just regular old poor site drainage. As you see from this picture here, it's kind of an indication there of water coming off a building and then probably not draining away from the building, but perhaps draining toward the building. It's just really always important to direct the water away from the structure. Also, probably one of the biggest offenders of allowing water to get into a building, cracks and joints in the foundation and in the walls below grade that aren't protected properly. Water will usually find a way to get into the building through those. Now let's talk specifically about cold fluid applied waterproofing. And when I say cold fluid applied, in other words, not a hot applied type of waterproofing system, which is often an asphalt-based system. You may have seen those. They usually involve a hot kettle of some sort, and the waterproofing is applied hot. So this is the opposite of that. This is something that usually is applied right out the pail, so to speak. So what are some of the advantages of this type of system? Well, it's usually very easy to apply, which means that it's more likely to be installed correctly, right? The easier it is, the more likely the contractor will install it correctly. It is a seamless system as opposed to, say, a sheet applied system. So when you apply this, liquid is just going to be continuous around the entire structure. You're not going to have to worry about any seams that overlap and protecting those. It does create a continuous waterproofing barrier that's fully adhered. This is important. There's not going to be any wrinkles or pathways behind the waterproofing layer where water could, say, travel parallel to the surface, which can create issues. You know, you could have a leak in one area of the waterproofing, and the water could travel parallel to the wall if it was allowed to do so. And of course, it could enter the structure at a totally different place. This type of waterproofing also adheres very well to surfaces that are not perfectly smooth, which honestly, from my experience, is not uncommon. So, you know, if surface prep is subpar, then liquid waterproofing can often overcome that and perform as expected. Now we're going to talk more about surface preparation and how we really want a smooth surface. But if you run across a situation where maybe that wasn't done properly, a liquid system applies to all those areas, so you still may be okay. So what types of cold fluid applied waterproofing are out there on the market? What are we looking at? Polyurethanes is one type. Polyurethanes flex pretty well. They have a lot of elongation properties that are favorable. But polyurethanes can also have a problem with immersion in water. They can actually re-emulsify from continuous immersion, meaning that they can revert from a cured state actually back to a soft state, kind of like when they were first applied. And that can create a problem because then they're no longer functioning as a waterproofing barrier. Polyethers, they're also in the polyurethane family, but they do hold up very well to long-term immersion in water. Polyethers will not revert, and they can be exposed to underwater conditions for long periods of time. Acrylics really don't have a lot of flexibility. Probably one of the big drawbacks to them. They can actually crack over time. Asphalt emulsions really don't stick well to each other. They are a lower cost option, at least they used to be, but they don't adhere well to themselves. So if you have to go back and overlap or put a second layer, they're not great at that. And we usually don't see many hybrid systems these days among the better performing systems. Most of them tend to be, say, polyether systems. So what are some of the important product design characteristics we need to look at? Well, right there, I tell you, we'll discuss wet and dry film thickness in a little more detail shortly. But single component products are almost always easier to install than two component products, which is a good thing. Less mixing, less opportunity for something going wrong. Some other things to consider may include what type of equipment is needed to mix there and apply the waterproofing. Will it be installed near occupied space? What may be the effect of solvent fumes if it's not a low VOC product? Say we're talking about waterproofing an area of an existing hospital or a school or something like that. That needs to be taken into consideration. And how will the weather impact the ability of the waterproofing to cure and dry properly? You know, is the waterproofing good after several hours? If you happen to catch a rainstorm, what are the temperature factors that are involved? These types of things all need to be taken into account. So talking about how thick to apply the waterproofing, the big message I would think here is that the warranty impacts the thickness. Now that may sound a little backwards. You may say, well, you know, the thickness should impact the warranty I'm going to get, but actually the warranty does impact the thickness. And what we mean by that is a thicker system will allow for a longer or larger warranty to be issued. So if you look there, say you want a 20-year labor warranty. Say you want a 20-year labor and material warranty. That may require a 2-layer 120 mil system to be applied, you know, maybe a reinforced system at that. Whereas if you just need a typical 5-year material warranty, like you see on a lot of projects, you may be able to just apply a single 60 mil layer of waterproofing, and that may be just fine for your project. So, you know, that just reiterating that the thickness of the system, the type of system, is it reinforced or not reinforced, that will affect the type of warranties that would usually be available for the product. So let's talk a minute about wet film thickness versus dry film thickness. What is that and how does it matter? So if you're trying to determine what your wet film thickness should be, in other words, how thick do you need to apply the waterproofing wet? Basically, you can see here, you just divide the final dry mill thickness by the solids percentage of the waterproofing product to get the wet mill thickness. So I'll give you a second to absorb that and kind of look at the middle point right there and kind of see what I'm talking about on the formula. You can see in that example, we want to end up with a 60 mil waterproofing layer, and then we have a waterproofing product that's only 80% solids. So we would divide 60 by 0.80, and that would give us 75. So what does that mean? That means you actually have to apply 75 mils of wet material. And the reason for that is that if a product is less than 100% solids, usually the remainder, say in this case, the other 20%, is a solvent. And what happens is as the product cures and goes through the chemical process of curing, that solvent evaporates off and you actually get a little bit of shrinkage. So what you need to do to compensate for that basically is to apply the material thicker, which of course means that you're using more material. And in this example we're showing here, if you were to look at the amount of material it would take to apply at 75 mils instead of 60 mils, you would actually be spending about 25% more on material. So that's important to keep in mind when you're considering, do I specify a product that's 80% or 50% or 100% solids? Keep in mind that the 50% solids product may cost less, but you're going to need to buy, in that case, you may need to buy 50% more product. So do you really come out ahead? And of course, that's extra labor time installing the product as well. So here we see some typical applications where cold fluid applied waterproofing can be applied. Plaza decks and balconies, elevator pits, tunnels, just to name a few of these. I've got a lot of them listed here. They are great for split slab applications like you might see in a parking garage. This type of waterproofing really has lots of uses both above and below grade, and we'll get into that. We'll show you actually later on some examples of that. Let's talk about the accessories. You have the main waterproofing product, right? The cold fluid applied waterproofing product, but then it's really a whole system. So we need to keep that in mind. It's not just the product, it's the system. So what makes the system? The accessories with the waterproofing is what makes the system. But it's really simple. Typically on a cold fluid applied system, you have joint sealants, reinforcing fabric sometimes, and a protection course. It's really about that simple. We'll also talk more about the expanding water stop in just a bit. I got a slide a little bit down the road. We'll go into more detail on that. But one thing I'd like to mention about the protection course on this, the most common type that's specified, which is really, technically it's a geocomposite drainage board is what it is. Often you see people just refer to it as drain board. It actually functions as both a drainage and a protection for the waterproofing, all in one product. I see specifications often that will list those two functions as separate items for accessories. Like they'll have a specification for the drainage, and then they'll have a separate specification for the protection board, which you can do. You can use some lesser functioning accessories to do those two things separately, but really typically what we see is this all-in-one drainage composite board, and it's really not necessary to have two specifications for the same function if you're using this type of product. Talking about the different types of application methods, there's really a lot of ways to apply fluid waterproofing. And honestly, many waterproofing products from the same manufacturers can be applied in more than one way. I mean, many products may say they can be roller applied, brush applied, or applied with a trowel. Some of them are spray applied. It just depends on the project, the applicator's preference, and of course, the manufacturer's recommendations. You always want to follow that. But you may find, like on a smaller project, perhaps something in tighter quarters, maybe they'll trowel apply it. Maybe a larger area where they have to cover a lot of square footage, they're going to use a roller or something similar. These are some of the typical substrates you'll find for liquid waterproofing. Concrete, CMU block, plywood decks, even insulated concrete forms. And we're going to show you some pictures of those here coming up shortly. In fact, I got a few slides here showing those different types of substrates. Here's a typical situation with a below grade foundation wall. As you can see, this is a poured in place type of wall system. That waterproofing would be applied to that outer face. And then of course, a protection layer would be put up, the drain board, and then the area would be backfilled with dirt. Here are some concrete decks. After waterproofing these decks, they may get something like tiles or maybe a pedestal and paver system or something like that as the finish surface on the deck. CMU walls that need protection. And look, if you look at that top right picture, you can see, you have to look closely, but you'll see where those walls have been skim coated. You can't see the mortar lines. They've been actually skim coated to create a smooth surface for the waterproofing. And that could be because when they built that block wall, they did not set the mortar joints flush with the wall. And you'd really like to see a smooth surface where the mortar joints are flush with the brick or the block. So that's probably why they went ahead and coated that wall, if not for some other reason where they can put the waterproofing on the smooth surface. Precast panels to be waterproofed, just like the concrete foundation walls we looked at a little while ago. Same type of application. It's just that these are tilt-up precast type panels. Same situation here as the concrete decks we just looked at, except these are precast panels for decking, panels and planks. They're precast off-site at a yard, and then they're brought on-site and assembled. You also see a lot of parking garages and things like this that are made this way, but same situation, they would waterproof this. In fact, looking at that picture on the right, there's a possibility they may actually pour a thin layer of concrete on top of that before then, say, waterproofing and putting their finished surface. And then here are those insulated concrete forms that I mentioned. One thing about these, they are made of like a styrofoam type of material. So as long as the waterproofing is not solvent based, you won't have a problem rolling it or applying it right on the outside of those forms. You obviously would not want to put a solvent based waterproofing directly onto styrofoam forms, as it would eat it away basically. And then we have plywood decks. This is very typical application you would see on projects like condominiums, apartment complexes, outdoor restaurants, this type of thing. And again, this may later be finished with some type of outdoor tile or stone or something similar. So let's talk briefly about substrate preparation before installing the waterproofing material. And I'll say that, substrate preparation, surface preparation is probably one of the most, if not the most important aspect of installing really any construction product, whether you're talking about waterproofing or concrete repair or flooring. Very, very important. It can make or break a project if it's done incorrectly versus done correctly. So depending on the waterproofing product that's used, some of the waterproofing products, they may require the substrate to be completely dry. Some will allow you to apply it to wet or damp concrete. Some are going to tell you that the concrete needs to be cured for a full 28 days before you can apply any waterproofing. And yet there's other products that'll tell you that you can actually, believe it or not, apply the waterproofing to green concrete after only, say, 3 or 4 days of curing, which is pretty incredible. So I don't know how often on projects the waterproofers are able to get in to waterproof a below grade structure, for instance, 3 or 4 days right after it's applied, but it is a neat aspect of waterproofing that can do that if necessary. As far as the properties of the substrate, concrete should always have a minimum of 3,000 psi before applying the waterproofing. But this is usually not a problem with most concrete mixes. Any structural concrete mix is usually going to be higher than that, typically 4,000 psi or more. It's also important that the concrete was cured using water or some other process that doesn't leave a residue on the surface, which could interfere with the bonding of the waterproofing. That's important. And that even includes, you know, formwork. If they use some type of form release, form oil, and then they pull the formwork away and they want to waterproof that, regardless of what, really of any type of waterproofing you're using, they're going to want to get all that residue off the concrete and make sure that they're applying the waterproofing to clean concrete. And I mentioned this briefly a few slides ago, but for CMU block, it's always better for the mortar joints to be flush with the face of the block, so you have a smooth, even surface for the waterproofing. So if it's a project where you know that you're going to be using CMU and you're going to be waterproofing that CMU, you would definitely want to specify that they finish the joints flush with the face of the block. Or if it's maybe a restoration project where there's existing block, they may do like you saw on the previous slide and skim coat and kind of fill in those joints so you've got a nice even surface. Anything you see like this on the surface of the concrete, that obviously needs to be repaired before applying any waterproofing. Holes, what you see here, say in the top left, is probably the typical bug holes you would see from concrete not vibrating out completely in the formwork. That just needs to be filled with some type of cementitious repair mortar or some type of skim coating like we were just talking about with the block. And any jagged edges or rough spots on the concrete really need to be grinded down. So you don't want to have anything, you know, you want to fill in holes, but you also don't want anything sticking up on the concrete that could say cut the waterproofing or you know, do anything to damage the waterproofing layer after it's applied. And of course, needless to say, that drop-in anchor sticking out in the bottom center picture there would need to be removed. You don't want to leave that there. So now that we know how to prepare the surface, let's take a look at the actual waterproofing installation process. So we've talked about accessories, we talked about preparing the surface, we talked about, you know, what is waterproofing, what is cold fluid water applied waterproofing. So let's actually see how the waterproofing is applied now, and talk, you know, some things about the actual waterproofing itself. I will say that waterproofing products in this category, really across the board, should not really, they're not made to be left exposed to UV, to the sun, for long periods of time. They're really meant to be covered up within a reasonable time frame. So that's another thing that kind of goes into maybe pre-construction planning, meeting with the contractor, this type of thing, because you don't want to have a situation where the contractor applies the waterproofing and then it's left exposed for, say, a week, 2 weeks, a month before he finishes the project, covers it up with drain board and backfills. Typically, they will be putting the drain board up and even backfilling within a matter of, you know, a couple of days or more. And I get asked this a lot. I do get asked about waterproofing ponds, you know, tanks, fish ponds, this type of thing. These products are really not recommended for ponds or tank liners. Can't even tell you how that may affect the tropical life in your pond. Also, you would be creating a situation there where it would be left exposed to the sun permanently, and we just said that you can't do that. Now, the only exception may be some type of between slab application, maybe where you had a concrete slab and then you waterproof that, and maybe you poured another slab on top of that, and that slab is what's exposed to your, you know, to your water. That may be an acceptable application. Talking about prep work and detailing, as I mentioned, is very important. The joint sealant, often a polyurethane joint sealant, will be used on all the inside corners to fill any non-structural cracks, and to fill any non-structural cracks in concrete, as you see on the picture on the left. So basically what they've done is that is where the wall meets the slab. And then they've done about a 3/4 inch cant strip, which means kind of an angled application of polyurethane joint sealant. And what that does, that allows for a nice, smooth, basically rounded transition of the water proofing material from the base up onto the wall without any sharp corners. And then they would also use a sealant like that if you have any very, say, 1/16 of an inch hairline cracks, this type of thing. You could cover them with a joint sealant. And then a detail coat of the actual waterproofing product will be applied along all the inside and outside corners, like you see in the bottom right picture there on the right. You can see they've gone up all around the corners, the edges, that bottom inside corner. It's about a 9-inch wide strip, maybe 4.5 inches coming out on each wall. So they'll put that before they then come back and coat the whole thing. And another thing you'll notice in that picture, all the little spots, the little holes are where the form tie holes were from their form work. So you can see they've actually done a really good job there of going back and patching all those holes and kind of grinding it down so it's smooth. Now we get to the primary waterproofing that we've been waiting for here. That would be applied in lifts or layers. Just depends on what the manufacturer recommends. The thickness of the layers, how many layers, this type of thing. I talked before about, say, a 60 mil layer, or maybe it's 2 60 mil layers, maybe it's a 90 mil layer, whatever it is. But basically, you want to do what's necessary to achieve the final dry film thickness, right? We talked about that. If it's a reinforced system, I should say, the reinforcing fabric would be embedded into the first layer of waterproofing before a second layer of waterproofing is applied, usually the same day. And I've got a slide here. I'm going to show you how that's done. And then once that system is cured, of course, the drainage board would then be installed. So here's kind of a neat step-by-step showing the installation of a reinforced waterproofing system. We talked about that. Let's say this was a 120 mil reinforced system where we had a 60 mil layer of waterproofing, and then we had the reinforcing fabric, and then maybe another 60 mil layer of the waterproofing. So first, you can see the first layer of liquid is applied in that bottom left picture, rolling that out. Then the fabric is laid on top. They're always careful to lay that out so it doesn't, it's not wrinkled. It's laid out flat and even. And then they'll lightly back roll that fabric. There, you see the guy there in the picture kind of using a roller. He's not applying more waterproofing at that point. What he's doing, he's just gently rolling, actually a dry nap roller over the top of the waterproofing. And what that's doing, it's just kind of embedding it into the waterproofing. And as it does it, it wets out. You can see it wetting out the fabric. And then after that has time to set up for a little while. It could be as soon as maybe 2 hours. The second layer of liquid waterproofing is rolled on top of that. And that would really complete the sandwich, so to speak, with the 2 layers and the reinforcing fabric in between. I mentioned earlier that circle back around to the expanding water stop. This is that, some people just call it that strip water stop. This is a really important accessory, though, for the waterproofing system, and not something to be overlooked. And most projects that you've probably dealt with that involve a wall meeting a slab, especially in an underground application, I can almost guarantee it had some type of water stop like this in there. It's basically rolled down right down the center of the cold joint, like you can see in these pictures. They have their rebar. They put that right down the center of where the wall will be, and then the concrete wall is poured on top of that. And that really seals out any water that tries to seep through that seam underneath the wall. Once it hits that, this water stop will swell to a certain point and block it from getting into the building. So let's talk briefly about the testing the waterproofing system for leaks once it's installed. This is probably something you would you would hire an outside company to do typically, a testing company. There are a couple methods that can be used when testing is required. One of them is called flood testing, which is pretty self-explanatory. Basically, water dams are put up around the area. All the drains are plugged and it's filled with at least 2 inches of water. And then after 24 hours, the system is checked for leaks. That's pretty straightforward. The other method is called electronic field vector mapping, also called EFVM for short. So the way this works, basically an electric field is created by applying water on the surface of the membrane and using the water as a conductive medium. So you have your surface that was waterproof, and then you have your waterproofing layer on top of that. And then they'll wet the surface on top of your waterproofing. And this instrument will deliver a low voltage electrical current between the waterproofing layer and the structural deck where the waterproofing is applied. If the waterproofing membrane is watertight, if there's no leaks, it'll isolate. It won't let any of that water that you put on top of the waterproofing seep through to the deck. You know, it'll obviously keep the deck dry, is what I'm trying to say. But if there's any leaks, what ends up happening is that water gets through the waterproofing and it makes contact with the structural deck, which also had the electronic monitoring pulse going to it. So now what you have is a completed current. So this electronic system can now detect where that leak is, and obviously you can set it up for repair. This is what that flood testing looks like. It just dammed off the area and filled it up. Kind of rudimentary here. And then here's that electronic testing method. You can see on the left there where they're hosing down, they're wetting that top. They don't need to flood the deck for this, by the way. This is not a flooding the deck type of process. They just need to wet the deck enough to where if there are any leaks, that water will find its way into the leak. And then you see on the right, he's running the instrument that makes the electrical connection and determines where a leak is. Actually a pretty neat process. So let's talk now about I'd like to show you a few CAD details. I'm not going to show you a lot of them, but just needless to say, we do have just about CAD detail for about every application you would need. So just to let you know, any type of project that you have, most companies will, MAPEI, most companies do provide CAD details, but I'm going to show you some of the key ones here. So here you see a typical foundation wall on a base slab. We talked about this a few times. You see right there where the expanding water stop runs down the center of that wall, a little black square you see on the far left, that's that expanding water stop. And then you see the beaded joint sealant in the corner running along the bottom of the wall. And then following that, you do see that detail strip of the cold fluid applied waterproofing, and finally the primary coat of waterproofing, which coats everything. This is the same thing, but it's a cross-sectional view that also allows you to see the drain board from the side. And one thing I don't, this type of project they're showing here, or this view I should say, doesn't show, but I do get asked about this a lot. You will also typically have some type of French drain system at the bottom of the wall. Usually consists of rocks for drainage, maybe some type of PVC pipe, something like this, so that once that water does drain down along that drainage board, it has a way to escape. And in a lot of cases, the construction plans will call for that water to be, diverted out maybe to a drainage area. And I did reference a couple of times split slab applications. Here's what that looks like. You see you have your base slab on the bottom there. Maybe think of this like a parking garage. Think of that base slab as being the slab, say, over occupied office space under a parking garage. And then you would have your waterproofing layer with the drainage protection board on top of it. And then you have a topping slab, and that's the slab. That topping slab might be, say again, using the parking garage example, that may be where cars are driving on top of that slab. So you know that any, you know, leakage you get, any rainfall, any anything you get from cars, you know, oil leaks, this type of thing, once it seeps through that top slab, it cannot continue through and get to the occupied space. And finally, here's a couple of details that show the inside and outside corner. I just wanted to show you this because it does show you that same situation we talked about, the detail coat on the inside corner. You see the joint sealant, and then you see the waterproofing layer, and then you do see the drain protection board wrapping all the way around that corner, or you know, around the inside corner. So finally, this is really important as we wrap up our AIA portion of this presentation. Let's highlight some of the waterproofing best design practices to keep in mind. First, it's always a good thing to insist on a pre-construction meeting to specifically discuss the waterproof. And I mentioned this earlier. You really want to have a meeting with everybody involved, the contractors, everybody on the site, maybe even the contractors who will be on the site in the same area right before or right after the waterproofers, because that can play a role in things. You don't want, for instance, the electrical contractor doing underground work to damage waterproofing that was already applied by the waterproofer. So important for everybody to be on the same page. Also, be diligent to cross-reference Division 3 and Division 7 specifications. So what do I mean by that? I'm talking about make sure that you're specifying the expanding water stops and things like, say, surface repair mortars in Division 3 in preparation for the waterproofing that you'll be specifying in Division 7, because they work hand in hand. We talked how much surface prep, you know, what an important role that plays in this system functioning correctly. So it's important to have the products that go along with the waterproofing, that go on before the waterproofing, done correctly before you do the waterproofing. And then, you know, it's important to insist, we talked about this a couple times, a smooth monolithic surface. Anytime it's possible to have a smooth surface, that's what you want. Sometimes that's not always the case, but whenever you can make that happen, that's very important. And if a CMU wall is to be waterproofed, we did talk about this several times now, make sure they finish the mortar joints flush with the wall whenever possible. And of course, as I've mentioned several times, always important to follow the manufacturer's installation guidelines. And that seems pretty straightforward, but it's probably one of the things that can get lost in the installation the most, where, you know, there were assumptions made or something wasn't done exactly like the manufacturer recommends. So that ends the AIA portion of our presentation. So with the time we have remaining, I think we have about 15 minutes of our time remaining, which works out great. I'd really like to introduce you to MAPEI's cold fluid applied waterproofing system and show you some different types of projects where it's been used. I believe it'll open your eyes to some new applications or some existing applications on your current projects. And then following that, we will open it up to any questions or comments you may have. So let's spend a few minutes talking about MAPEI's primary cold fluid applied waterproofing system, which is the Planiseal CR1 system. Great system, great product. So what distinguishes the CR1 system from others? Well, there's a lot of great features with this system. First of all, it is a 100% solids product. You saw me referencing a couple times, especially when we talked about wet film thickness versus dry film thickness, and how anything less than 100% will actually shrink, and you'll have to use more product. Well, you don't have that issue with MAPEI CR1 because it is a 100% solid. So what does that mean? Well, that means that if you apply it 60 mils wet, it's gonna dry to 60 mils. So there's no guesswork involved. It also makes it very easy to figure coverage rates. So you can look at a project and figure your square footage, look at the data sheet, get the square footage that, per pail, and figure it out pretty easily. CR1 is also a single component product, which is really nice. I mentioned how single component tends to be better than two component because it's just an easier product to use and install, less room for error. It is easy to apply the product. It honestly, it can be applied by roller, trowel, brush, but it's applied right out the pail. There's no priming. They just open up the pail and apply it to the surface. And it does allow for vertical and horizontal use in one product, in one bucket. This is really, I don't know if it is kind of unique in the industry in the sense that you don't need to specify or order one waterproofing formula for horizontal applications and then include another specification for vertical, one that maybe has to be roller applied, one brush applied. This CR1 will do all those things in one product. One formulation that does all of that. It makes it a lot easier. Another thing I'll mention is that CR1 is not an asphaltic type product. It is a polyether, which if you remember when I was talking about the different types of products, polyethers are very good with long-term water immersion. So you won't have the problem with CR1 re-emulsifying because, say, the water table comes up and it's just sitting underwater. It's not going to be an issue. The other thing with it being a polyether means that it's also very low odor. It has a very, very, very low VOCs, next to nothing. It doesn't give off any solvent fumes, which is really important because the contractor with this type of product, he's almost always working very close to waterproofing. In fact, he's usually right on top of it. Sometimes in confined areas, like a below grade situation, he's in a small trench, basically, with that wall right in front of his face, and he's applying waterproofing. And I can tell you, and I've been there, if you've ever stood anywhere in the vicinity of a solvent-based waterproofing product, like an asphaltic type product, on a hot summer day, 95 degrees, it'll knock you back a little bit. It's hard to work around it. This CR1, you can literally be right on top of it, and it has virtually no odor and no ill effects. Another neat thing about CR1 is that it can be applied to green concrete in just 3 days after curing, and after 3 days of curing. So when I was talking earlier about some products will do that, this is one of them. So you could literally pour a slab, pour a wall, and if the project called for it, you could have the waterproofer in there in 3 or 4 days and start applying to that wall. And once it's applied, once the CR1 is applied, it's rain resistant in as little as, let me get my pointer going here. Yeah, it's rain resistant in as little as 2 hours. And the reason for that is that it skins over in about 2 hours. So what does that mean? I don't know what area of the country you live in. I know here in Louisiana, other areas, Florida, if you live up in the Northwest, there's a lot of areas of the country where you'll get these pop-up showers, unexpected showers. You'll get a lot of rain, and it may be a sunny day, but so you're applying your waterproofing, and all of a sudden a storm cloud moves in and pours down. Well, what happens if the waterproofing is not resistant to that? Well, I'll tell you what happens. It washes all down the wall, and you're going to have to start all over. So The good thing about CR1, in just 2 hours, you're good. You're protected from rain for the most part. And then you can see at the bottom there, if you can see, I know it's kind of small, but you can see all the types of surfaces where CR1 can be applied. It's very versatile product. Let's see here. So MAPEI, I talked about the accessories. MAPEI does manufacture all of the accessories for the system. Drainage board for vertical applications, horizontal applications. There's our reinforcing fabric. We have the 2-part and the 1-part polyurethane joint sealants. There's a tongue twister for you. And we do have the expanding water stop that we talked about. So we've got everything you need to make a complete system. So let's, now that we know that, let's look at a few projects where the CR1 system has been used. This right here was a really great project up in Pennsylvania. It involved waterproofing over 35,000 square feet on top of several existing underground parking garages. So the old waterproofing that was down there was removed. And then here you see the contractors applying the CR1 to the prepared surface on the ground. It's on the ground, but it also happens to be the roof of the subterranean parking garages. And then once that's done, you can see here the finished project with landscaping and driveways. So that whole area where you saw them waterproofing, now it's got, it's got dirt, grass functioning normally, and of course the parking garage is waterproof. This right here was a really great example. This was a project in Louisiana that involved one of those new oil change facilities. You see these all over the place. Your quick oil change facilities. Whether you knew it or not, they actually have an underground area pit where the workers are down there to change your oil. You see in the upper left there, that's a picture I showed you earlier with the detail around the edges. And then you can see on the right there, you can see the contractor, he's checking his mills, making sure it's 60 mils thick like this project called for. And the good thing again is he didn't have to think about how much thicker to apply the waterproofing. He applied it 60 mils and he knew it would dry at 60 mils. And there you see the fully coated project in the middle. And then following that, you can see where they applied our MAPEI 25 drainage board. Now this is something we're really excited about. This is a great application for CR1, really great application, finding its way in, I think, into more and more projects. This is a situation, or I should say a design that allows for thin set tile to be placed directly on top of the waterproofing without the use of any drain board. So what this does, it not only simplifies the outdoor flooring system, but it also greatly reduces the thickness of the system where that's a concern, such as think about like maybe a doorway opening out onto a balcony where you only have so much clearance, after you put your tile and everything, you don't want the waterproofing to be taking up a lot of height there. The way it works, it's a 1 or 2 coat reinforced waterproofing system that's put down on the surface, and they follow that with just a very thin skim coat of CR1 with a full sand broadcast into that skim coat. So basically, once that's cured, that becomes the surface to bond your thin set tile mortar to. And furthermore, keep it something in mind that if you specify and install MAPEI tile mortars and grouts for an application like that, MAPEI will warranty the entire installed system, the waterproofing, the thin set mortars, the grouts, and not to mention any kind of repair mortars that were used to prepare the surface before the work began. So, one manufacturer, one complete warranty, and not many companies can offer that. Here's a great example of what I'm talking about that use CR1 for direct application. You see there on the left, that is after the first coat of Planiseal CR1 with the reinforcing fabric applied to it. And then you see the middle picture is after they've applied the second coat of CR1. And then on the right there, what you're looking at is the prepared sanded surface with the sand broadcast to which they will bond the tile. This is another similar application. You can see they've detailed the edges of that hallway on the left. And then you see on a balcony, on a plaza area, the CR1 applied. And I can tell you, this was another project where they did the same sand application. They put the CR1 down, put the sand down. I just don't have a picture of the sand stage, but you can see from the middle and right pictures there, that is after the tile has been applied. Of course, the tile had not been, cleaned or sealed at this point, but you can see how nice that looks. And it's an outdoor system, and it's fully waterproofed. This was a nice large plaza deck. This was a pool deck. Great product for pool decks, by the way, if you're going to be putting down tile or pavers or something like that. And then you can even see those large planters. They waterproof the inside of those with CR1. If you look closely, you'll see the green in there. And then, what they'll do is they'll just fill those with dirt. And so it's a great product for waterproofing these types of rooftop planters. And this is an area of that same deck, deck you just looked at. I just like this because it really shows the seamlessness of the CR1. I mean, that area right there is, it's waterproof like a bathtub. So there's no opportunities for water to leak there. And then finally, this was a really nice project in Florida where CR1 was used to waterproof and more outdoor balconies and plaza decks, except this application called for drain board. That's how it was specified, and it worked in conjunction with all those drains you see. So the drain board helps to move the water to those drains. Nice project over there. Something we're really excited about at MAPEI, Planiseal CR1 waterproofing systems have just been approved by the Miami Dade County board to comply with the stringent Florida building code, including the high velocity hurricane zone of the Florida building code. And as you probably know, Florida has some of the strictest building codes in the US. So it's really great to see MAPEI waterproofing meeting, all those, some of the highest standards that are out there. And as we close out, I just want to ask you to, take an opportunity to check out MAPEI's website. You'll find really everything you need for product information, specifications, the CAD drawings I was talking about, project profiles, even product calculators. They've got some really great calculators if you need to figure out how much material will be used on your job. And MAPEI is also found in sites like RCAT, MasterSpec, SpecLink. Our products are in there. So if you use those services to write your specs, please check us out there as well. And then I would also encourage you to check out the MAPEI app for your phone. Very helpful. I use it every day. Well, that concludes the presentation. Thank you all so much for tuning in. I know our time is very short here, but I'd be happy to answer any questions we have. Jen?
Thank you, John. That was a great presentation, or I should say presentations, kind of a 2-for-1 there at the end.
Mm-hmm.
We do actually have some questions. Very quickly, somebody is wondering, is there a high temperature limit for CR1 when it is in use?
Yeah, CR1 should be applied. It really needs to be applied. The temperature range is 40 degrees to 95 degrees. So it's typical for most waterproofing applications. It is not something that is meant for a very high temperature, like hundreds of degrees or something that would withstand that. But the application temperature is up to 95 degrees. So you should be able to cover most applications with that.
Very good.
Thank you.
Another question, is CR1 okay in pools before tile installs?
CR1 would work if you're talking about say a concrete sub base and then waterproofing. Now, as far as the tile application, if you're talking about the direct over tile method, give us a call. It's something we can talk about. The challenge there is applying the sand to a vertical surface and getting full coverage. That can be a challenge. So that would be something to think about. but it can be applied as part of kind of a sandwich system. So please, yeah, I'll reach out to us so we can talk specifically about your project.
Absolutely. If CR1 doesn't work, we definitely have other
We do.
solutions. That's for
Yes, we
sure.
do.
Pools are something we do. When is the mesh required? That's another question here.
Yeah, the mesh, we encourage the mesh to be used in that horizontal deck type application I mentioned. It's not necessary, but we do prefer it. But the mesh is really, I'll say honestly, is up to you, is up to the designer, and it's going to add some cost, but it depends if you want a longer warranty. So if you want, say, a 15 or 20-year warranty, then we would tell you need to use the mesh. If you're saying, well, I only need a 5-year warranty, then we probably wouldn't recommend that you need to use the reinforcing mesh. So it really depends mostly on the warranty needed.
Very good. Well, I always say this. I know when I hang up these webinars, I always think of a few questions. And if everybody's like me and that happens, please do send those questions to MAPEI Digital at mapei.com, and we'll be sure to get them to John. But John, thank you so much for a really great webinar, and everybody, thank you for joining us. We realize that your days are full and you're busy, and we appreciate you spending some time with us. And again, part 1 was AIA, and if you are joining us live and interested in those credits, send us your information to MAPEI Digital at mapei.com, or drop it in the chat there, and we'll be sure to get that off to you. All right. Thank you again. Have a great rest of your day, everybody.
Thank you. Y'all have a great day. Appreciate your time.
Bye-bye.
Bye.